Welcome to Calculus. In this video, we're going to be focusing on a unit on the derivative in the tangent line problem, but specifically talking about finding the tangent line based on a parallel line. A really good problem that comes up quite frequently in calculus classes. All right, before we move on, please don't forget to subscribe and like and hit that notification button as well for me. I'd appreciate it. All right, so here is the type of problem I'm talking about. Find the equation of the line that is tangent to the function 2x squared minus 20x plus 46 and is parallel to the line 4x plus y equals negative 9. So a lot of times, to wrap your head around exactly what this question is asking, drawing a picture really helps. Oftentimes a picture is worth 1,000 words, especially with a question like this. So here's what I did. I went and used Desmos. You can also use a TI-84 graphing calculator or any other graphing calculator as well. I drew a picture of my function. So in red right here is my function. In blue is the line that I want to be parallel to. And the question asks for me to find a line that is tangent to my function in red and parallel to my blue line. So let's see if I can try to roughly draw this line that I'm looking for. This is just purely for picture's sake. Something along the lines of this green line right here that is tangent to my given function and also parallel to my blue line. That's the line I want to find. That's the line I gotta find. Now, how do you find the equation of any line? Well, there's two things you need. You need the slope, m, and you need a point x, comma, y. So if I can find the slope of that green line and I can find a point on that green line, then I could pretty easily find the equation of that green line. Let's talk about the first slope. We know that parallel lines have one really important thing in common. They have the same slope. So the good news is if I can find the slope of that blue given line, I already know the slope of my green line. Now that blue line had an equation of 4x plus y equals negative 9. If I put this into slope-intercept form, all I got to do is subtract the 4x over. I get negative 4x minus 9. So that means the slope of my given line is negative 4, which also means if I'm going to be parallel to that given line, I need to have a slope of negative 4 as well. So the only remaining thing I got to find, it's going to involve a little bit of work, is finding the point, specifically the point of tangency, somewhere around here. The point where my green line is tangent to that given function. Now, to do this, I'm going to have to work backwards. Hear me out. Parallel lines have the same slope. Already mentioned that. So I already know what the rate of change of my tangent line is. Again, that's the negative 4. What I need to know is the point on my function at which the tangent line is, well, tangent. I need to find that point of tangency. Now, here's where the derivative is going to come in. The derivative is a formula for the slope based on x. So if I know the slope already, I could set the derivative equal to it and solve for the x value that creates that slope. Let me explain that one more time. What is f prime of x? The derivative. The derivative is a formula to find what? The slope. But if I already know the slope of my line is negative 4, then I could set my derivative equal to negative 4 and work backwards to solve for x. X is the point of tangency right here. That's my x value that I'm trying to find. And if I find that x, I could plug that into my function to get y, and boom, I'll have the point that I need. So I need to find the derivative first. So here is my work to find the derivative of 2x squared minus 20x plus 46. I'm using the limit definition to find the derivative. Please pause if you need to, walk through, understand how I did all of my work, but I arrived at a derivative of 4x minus 20. Work is pretty easy, not too difficult, but again, pause the video, check it out, go through it one by one, step by step, and make sure you understand it. So now again, I'm going to circle back to the idea that I know my slope already, and what is a derivative? It's a formula to find slope. So I'm going to take my derivative, and I'm going to set it equal to my slope. And this is going to allow me to solve for x. And again, what is this x? It's the point of tangency. All right, so my derivative is 4x minus 20. The slope of my line that I already know because I'm parallel is negative 4. Now all I got to do is solve. Add 20 to both sides. 4x equals 16. Divide both sides by 4. And x equals 4. So the slope of my line is -4, and my x-coordinate of my point of tangency is 4. That goes all the way back to the x-coordinate of this point right here. And based on my terrible drawing, it actually does look pretty accurate to be right around an x value of 4 there. So now the only remaining question is what's y? Well, how do you find y? That's what the function is for. That's what functions do. Remind you that the function is 2x squared minus 20x plus 46. Now, I sometimes forget that I got that wrong. Nope, that's right. 2x squared minus 20x plus 46. So how do I find y? All I got to do is take my x-coordinate that I found by solving and plug that in. Remember, plugging 4 into your function gets the corresponding y value. So that's 2 times 4 squared minus 20 times 4 plus 46. And you know what? Don't be afraid to grab a calculator if you need to. 2 times 4 squared, which is 16, minus 20 times 4 plus 46 is a beautiful, whopping -2. So that is the y-coordinate of my point. I now have everything I need, the slope and the point of tangency, and now I could put them together to find the equation of my line. All right, so let's go ahead and actually create the equation, and this is where I'm going to tie everything together. So once again, the slope is -4. The point is 4 comma -2. So here I go. I prefer to use point slope form. Point slope form is y minus the y-coordinate of my point times, or equals, the slope times x minus the x-coordinate of my point. Everybody wants to find equations of lines a little differently, but I think this is the easiest. So I'm going to do y minus my y-coordinate of -2, my slope of -4 times x minus my x-coordinate of 4. Now I'm going to be honest, we could clean this up a little bit and write y plus 2 equals -4 times x minus 4. Listen, there's actually nothing wrong with stopping right here and labeling this as your final answer. The question did not specify to find an equation in slope-intercept form or standard form or any specific form. So once you use point-slope form, you have an equation. Doesn't matter if it's not in a specific form, it is an equation. Obviously, we could go ahead and distribute that -4 to get y plus 2 equals -4x plus 16. We could go ahead and subtract the 2 over, and we get y equals -4x plus 14. That would be the equation in slope-intercept form. We can actually add the 4x over and get 4x plus y equals 14 if we're asked for standard form. But the point is, whether you're using slope-intercept form, standard form, or point-slope form, they're all equations of lines. All of them are good to go. So what is it that we just found? We found the equation of this beautiful green line right here that is parallel to the given line in blue and tangent to my given function. All right, let's do a second problem here. If you'd like, you could pause the video, try it on your own, and see what happens and see if you get the right answer and fast forward to the end. All right, find the equation of the line as tangent to the function f of x equals the square root of x plus 5 and parallel to the line -x plus 4y equals 22. Once again, I truly believe a picture's worth 1,000 words, so I went ahead and Desmos and graphed this. In red, I have my function, and blue is the line that I want to be parallel to. So I'm going to kind of just estimate somewhere, I don't even know, again, it doesn't have to be perfect, but just to try to give myself an idea. Somewhere right around here would be my point of tangency that would create a line that is tangent and parallel to the given line. Now, once again, if I'm parallel, I already know my slope. So the equation of this blue line was -x plus 4y equals 22. So I can go ahead and put this into slope-intercept form, add the x to the other side, divide everything by 4, and I get 1/4 x plus 22/4 or 11/2. But the key thing I need there is the slope. So if the slope of the given line is 1/4, the slope of my green line that I'm trying to find is also 1/4. And again, what's the connection to a derivative? The derivative is a formula to find the slope. I already know the slope, so I could set the derivative equal to the slope and it'll allow me to solve for the x value of this point right here. I need that x value. I can then find that y value with that x value, and I'm all good to go. So I need the derivative. Here is using the limit definition to find the derivative of the square root of x plus 5. Please take your time to walk through this, make sure I didn't make any mistakes. But this should be the correct derivative using the limit definition. 1/2 times the square root of x plus 5. All right, so now what I have to do, and again, pause the video if you need to right here to process all of my work there, but hopefully it makes sense. So now what I'm going to do is the idea that the derivative is a formula to find the slope. I know what my derivative is. I know what my slope is. I could set them equal to each other and solve for x. All right, I'm actually going to lead by cross multiplying here. So I get 2 times the square root of x plus 5 times 1. And 4 times 1 is 4. Then I'm going to divide by the 2 out in front here. So I get the square root of x plus 5 equals 2. Then I need to get rid of that square root. So I'm actually going to square both sides completely. On the left-hand side, the squared square root are going to cancel, and I get x plus 5. On the right, I get a 4. Subtract the 5, x equals -1. There is my x coordinate. Once again, I already know the slope is 1/4. I now know the x coordinate of my point of tangency. That is this point. Again, I mean, I didn't make a bad picture. It looks pretty accurate to be right at -1. Now I just have to find my y coordinate. To find the y coordinate, use the original function. The original function was the square root of x plus 5. Functions find y values with the given x. So I'm going to plug in -1. -1 plus 5 is 4. The square root of 4 is 2. So there is the y coordinate of my point. Now, like I did earlier, I just got to put it all together. The slope of my line is 1/4. The point is -1, 2. Again, make sure you understand how I got that x and how I got that y. Now I got to put it all together using slope-intercept form. Y minus my y coordinate of 2 equals 1/4 times x minus my x coordinate of -1. Clean that up a little bit by simply changing that to an x plus 1. Again, I could stop right there and be totally happy, but obviously I could continue to put it into a different form. 1/4 x plus 1/4. If I do a little bit of distribution, add the 2, I get y equals 1/4 x. 1/4 plus 2 is 2.25, which as a fraction, if you want to keep everything in fractions, would be 9/4. So again, whether you are asked to put it in any form, then this answer would be totally fine. If you need specifically y-intercept form, you could do that right there. You can even do standard form by multiplying everything by 4. You get 4y equals 1x plus 9. Subtract the x over, -1x plus 4y equals 9. That would be standard form. Any form is fine with me, unless specifically stated. They all are equations of lines. And if you go all the way back to the picture, the line that I just found is the equation of that green line. That is, again, both parallel to the given line and tangent to the function that was given. All right, hopefully the problems make a lot of sense, and they're pretty easy. Sometimes the toughest work is find the derivative and or the solving portion, but hopefully it's not too bad for you.